Okay, so in this lesson, we are going to revise a question to do with more concept in a past paper. This is a question that I have here. All right, we are considering a question from Science Paper 2 Chemistry 2014. We have question B5 there. The question says, magnesium carbonate decomposes on heating to form magnesium oxide and carbon dioxide. Right, so what it means in chemistry when they say to decompose is simply to break down from a larger compound into smaller compounds. All right, so now the first question is saying construct a chemical equation for the decomposition of magnesium carbonate. Include state symbols. The question was carrying 2 marks. So we need to know the chemical formula for magnesium carbonate for us to write this equation. So in simple terms, when writing chemical formulas, this is how we go about them. So in this compound, magnesium carbonate, we have two things. We have magnesium, a metal. We also have a radical, which is a carbonate. Carbonate is CO3, like that. Okay, so these are the steps that we consider when writing chemical formulas. So magnesium has a valence of 2. We put it on top there. Carbonate also has a valence of 2. We put it on top there. So for magnesium, how do I know the valence? It is found in group 2. And for metals, the group number determines the valence number. There is magnesium in group 2. Now, carbonate is a radical. It has a valence of 2. You just have to master the valence of carbonate, especially the valence of radicals. All right, what do we do from here? We exchange the valences. The 2 goes there. This 2 comes there. So we are going to have Mg2C. Now we are going to put this radical in brackets so that we separate these 2 from that 3. CO3 with the 2 outside the brackets. Now, if we have two common numbers, if we have numbers in short which are divisible, we divide them. So 2 into 2, that is 1. 2 into 2, that is 1. The ones we do not show. So the correct chemical formula for magnesium carbonate is MgCO3, like that. Okay, so we're going now to write the equation to show the decomposition of magnesium carbonate into magnesium oxide and carbon dioxide and carbon dioxide. All right, so the equation will look like this. Magnesium carbonate, mind you, it is not reacting with anything, it is simply decomposing. So magnesium carbonate decomposes into magnesium oxide, like that, plus carbon dioxide, CO2. Okay, the question has specified to say include state symbols. So magnesium carbonate is a metal carbonate which is a solid. Magnesium oxide is also um, a metal oxide which is a solid. Carbon dioxide, this is a gas. We put a small letter G, like that. We have constructed the chemical equation. This is for A. For B, calculate the relative formula mass of magnesium carbonate. The relative formula mass of magnesium carbonate. So we have three things. We have got what we call the RAM, which is the relative atomic mass. We have got the other one, which we call as the relative formula mass. We also have got what we call as the MR, or in short, the relative molecular mass. We call it as the MR, relative molecular mass. All right, so the relative atomic mass is simply the atomic mass number of an element on the periodic table. Okay, the relative formula mass is the mass of a compound. Okay, the total mass of all the atoms present in a compound. All right, same applies to the relative molecular mass. It is simply the the total mass of a molecule. All right, so we are going to write what we call as the relative formula mass of magnesium carbonate. So magnesium carbonate is we are going to write first of all the formula MgCO3. Then how do we go about writing the formula mass? We checked the number of elements that are there. We have magnesium Mg, we have carbon and the oxygen. Then we are going to count the number of atoms present for each element in this compound. So for oxygen, we have 3 atoms multiplied by the mass number for oxygen. The mass number for oxygen is 16. So we are going to multiply 3 by 16. Carbon here, we only have 1 atom. We don't have any number for carbon. So we have 1 atom of carbon multiplied by the mass number for carbon, which is 12. There, that is the mass number for carbon, it is 12. Magnesium, we are also only have 1 atom multiplied by the mass number for magnesium on the periodic table, which is 24 there, 24. So 3 by 16 gives us 48, 1 by 12 gives us 12, 1 by 24 gives us 24. So the relative formula mass, we had the sum of these masses. So we are going to say 48 plus 12 plus 24. This should give us 84 as the relative formula mass of magnesium carbonate. So this is the answer. All right, from there, we look at question C. Question C is saying, given that 21 kg of magnesium carbonate is heated, calculate the mass of magnesium oxide formed. Okay, so we have this equation here for question C. We have magnesium carbonate being heated to produce magnesium oxide plus carbon dioxide gas, like that. Now they are saying, given that 21 kg of magnesium carbonate is heated, calculate the mass of magnesium oxide formed. All right, so we need to find the mass of magnesium oxide. Now we need to collect the data that we have about magnesium oxide. This is a more concept question to do with stoichiometry. So we are going to check for magnesium oxide. The only information, first of all, we are looking for the mass of magnesium oxide, of which we don't know. The other information that we have the chemical formula there, and it means we can find the molar mass. So we can find the molar mass for magnesium oxide. Let's find it. So magnesium oxide has got magnesium and oxygen. So we have 1 atom of oxygen multiplied by 1 atom of oxygen, okay, multiplied by 16. We also have 1 atom of magnesium multiplied by 24. This should give us 16 plus 24. This, when we add the 2, it is giving us 40. Is it 40? Yes, it is giving us 40. Now, since it is the molar mass, we'll put grams per mole, like that. So we have found the molar mass for magnesium oxide. All right, bear in mind to say, as long as the question is saying calculate the mass of magnesium oxide formed, then the formula that we should consider is this one, which states that number of moles is equal to mass divided by the molar mass. Have you seen? And then to use this formula, we simply make mass the subject of the formula, of which when we cross multiply, mass will be equal to number of moles multiplied by the molar mass. So we have found the molar mass. We need to find the number of moles. So how do we find the number of moles? How do we find the number of moles for magnesium oxide? There is only one possible way to find this number of moles, and that is by using now what we call as the stoichiometric ratio. We are comparing two things here, magnesium carbonate and magnesium oxide. So we are first going to find the number of moles for magnesium carbonate. Okay, so when you look at the equation here, the mole to mole ratio, we state that it is 1 to 1 because we have one more, we don't have any number in front of magnesium carbonate. So it means that we have one more of magnesium carbonate decomposing into one more of magnesium oxide like that. So let's find the number of moles for magnesium carbonate. Okay, we'll say number of moles is equal to mass over molar mass. We have been given the mass for magnesium carbonate, which is 21 kg. Now, we don't use masses in kg, and the more concept, it has to be in grams. So we are going to convert from kg to grams. How do we convert? This is how we go about it. Okay, to convert from kg to grams, from kg to grams, we multiplied by 1,000. To convert from grams to kg, we divide by 1,000. Okay, so we are converting from kg to grams. In short, we are going to say 21 multiplied by 1,000. It is giving us 2, what is this? Okay, this is 2100 like that grams. So we have converted from 21 kg to grams. So we are going to use the formula now. The formula is saying number of moles is equal to mass over molar mass. So the mass now is this one, 21000 grams divided by the molar mass. Now the molar mass is simply the formula mass expressed in grams per mole. We have already found the formula mass for magnesium carbonate. So this same formula mass, we are just going to put the units, which is the grams per mole, then it will become a molar mass. So we have 84 grams per mole. The gram and the gram cancels. This number divided by 84 should give us 250. So the number of moles is equal to 250 moles of magnesium carbonate. Now, since the mole ratio is saying that 1 mole of magnesium carbonate is decomposing into 1 mole of magnesium oxide, then it means that 250 moles of magnesium carbonate would produce 250 moles of magnesium oxide like that. Then we go ahead and find the mass. So the mass for magnesium oxide is equal to number of moles, which is 250, multiplied by the molar mass. We have already found the molar mass for magnesium oxide, which is 40 grams, multiplied by 40. This gives us 10,000. 10,000, okay, 10,000 grams of magnesium oxide would be formed. All right, so that is what it means. Okay, question D. Question D is saying name a metal carbonate that would not decompose on heating like magnesium carbonate. So this question has to do with the reactivity series of metals. Metals in group 1 are very reactive. They form stable compounds that do not decompose easily. In short, group 1 metals, lithium, sodium, potassium, these metal carbonates do not decompose on heating unless the group 2 and the transition metals. So a metal carbonate that would not decompose on heating like magnesium carbonate, we can pick any carbonate from group 1. We can have sodium carbonate. If we want, we can also have potassium carbonate. potassium carbonate. So these metal carbonates would not decompose on heating like magnesium carbonate. These were the answers for this question 5 in Science Paper 2, 2014.